Okay, so this video is going to be on exponential growth or decay word problems. And to start, I just want you to look at and write down this formula that we will use to model exponential growth and exponential decay. We have y equals a times e to the k times t, where y is going to represent our ending amount, a would represent our beginning amount, and then if k is positive, then that would represent growth. If k is a negative number, then that would represent decay. And then we would also have where t would be time. Okay, so we're just going to go through some scenario examples for these types of problems. So, and I don't know that it's necessarily important for you to write everything down. I will go ahead and link this sheet on online, but I would like for you to be trying the problems as we go. So we have Jim invested $1,500 into his credit union account, which pays interest compounded continuously. After 10 years, his account had grown to $2,260. Find the interest rate rounded to the nearest 1/10%. Now, I know I just went through this model up here talking about exponential growth or decay, but this is actually an example where we need to use the A equals P times E to the raised to the RT power. So you might have some, there we go. You might have some where you're going to use this compound interest formula. So the first step I want to do is I want to plug in things from my description. A is the ending amount. So that would be this $2,260. P is the principal or starting amount. So I would want to plug in $1,500. And 10 years right here would be my time. So I'm going to want to plug that in, and my unknown is the rate. So first step, plug in values to the equation. And now I need to solve this, meaning I need to get that R to be by itself. So the first thing I would do would be divide both sides by 1,500. Again, I'm trying to get that E by itself. Now, if I want to bring down that variable, 10R, I'm going to natural log both sides. Then remember, the natural log of E is just 1, and that will allow that exponent to come down. So there is the natural log of 1.507, and then I have 10R. Then I would divide both sides by 10. That is the decimal representation of my rate. So now I want to multiply by 100 to convert it to a decimal, or convert my decimal to a percent. So he had a 4.1% interest rate. So you kind of have to pay attention to what the question is asking, because this one was asking about finding the rate. So let's practice another one with this. So now my suggestion would be that you pause the video and try to do the problem before I go through it. So we have Joan invested her money into a bank account that pays 5.25% interest compounded continuously, and that continuously is important. After 12 years, I know I'm going to need that 12, her account totaled $3,943. Find the amount she originally invested. So now would be a good time for you to pause the video and try this problem before I go ahead and go through it. Compounded continuous formula is A equals P times E raised to the RT. Now I need to think about what I was given from up above. I know A, that was the $3,943. I don't know P, what she originally invested. E is our just space E. R is 5.25 and T was 12 years. Now, I need to plug everything in. Biggest mistake, notice this next line down. Some people do not convert that 5.25 to a decimal, and you will get an incorrect answer if you do not do that. So you need to convert your interest rate to a decimal. So there's everything plugged in. If you didn't have this set up correctly, try now to go ahead and figure out the rest of the problem. So again, I'm solving for P. I need to move this E over, and you should be able to just figure out what that E value is. So I'm going to go ahead and simplify my exponent. Then I'm going to use a calculator to evaluate 0.63 e to the 0.63, and that's being multiplied times p. So now I'm going to go ahead and divide both sides by that number, and that is her principal amount she invested, and then it said to round to the nearest cent, so $2,100.01. Now at the bottom of this page is another problem. I'm going to go ahead, not at the bottom of that page. I do have a couple of more problems based on compounded continuously. However, I would like to go ahead and keep moving along, so I'm going to post this online for you to look at. Okay? So I'd like to move on. In part 2 of my video, I will talk about some other problems that do not have to do with compounded continuously. So stay tuned for part 2.